This problem depicts a plane taking off of a runway in this direction here. Now this is a problem of reference frames. There's 3 different reference frames and their orientation with one another. And typically in those types of problems you're going to have complicated geometry used to trick you up to make sure that you understand what's actually going on. You can't fumble your way through this problem well. So we know that we're going to have to be looking at geometric functions and whatnot. So the 2 positional unknowns that we have are this gamma, which relates where the plane is taking off from, and the orientation of the tower. And we're also missing the distance that the plane is from the tower. The tower is right here. That's tower T. So if we were to pull off those vectors, it's much easier to look at them. This is the x direction, which is one of our reference frames. We have x and y here. And we have v, which is v and its perpendicular component here. Then there is r, which is this direction and its perpendicular component here. So those are the 3 reference frames. And we know some information about these orientation because this is given to us as 50 and this is given to us as 20, where this is the velocity and this is r. So we can find this gamma, which is the difference between r and that velocity of the plane's direction, by subtracting 50 plus 20. So that's 50 minus 20, and that equals 30. So now we can put in our knowns that we know that gamma equals 30 degrees, which is really great. Now the next thing that we'll solve for is this r direction here. And that becomes a little bit more complicated. When I'm looking for something like that the positional distance is over here and the angle is at a different location, I like to pull off those 2 coordinate systems and put them on one another. So that means that if we were to take the velocity here and its perpendicular orientation and then put in a r here, we would find that gamma is situated here, and gamma is situated here, here, and here. What we need is this distance in this direction. So using this angle, you can either solve for this being 60 or this side being 30, and you can use that r sine of 30 equals 500. We know that the perpendicular distance here is 500. Or you can use r cosine of 30 equals 500. Cosine of 60 equals 500, because that perpendicular distance is also repeated over here. And you get a nice square, or rectangular in this case, and you can solve for those directions. Doesn't really matter which way you do it, but you'll find that r equals 1,000 feet. So now at this point we can put in r equals 1,000 feet here, and we solve for all the positional variables in this problem. Now let's get to converting the theta dot and r dot. So we have that r dot is in this direction, v is in this direction, and we have an angle of 30 here. Well, the magnitude in this case is given to us as 140 feet per second. So you just put in the component for that, which would look like r dot equal v cosine gamma equals 140. And when you plug in the value for gamma, which is 30, you'll get 161.7 feet per second. So that is solving for the first one. Once you take it apart, you realize it's not that complicated. We've been doing components since day 1. So this is another component portion. Solving for theta dot, though, is a little bit more tricky because you have to recognize that when r dot is in this direction, its perpendicular component is r theta dot. This is also sometimes called v of theta but I like putting in what it actually is because it helps me remember more clearly. But once you recognize that, you get, this is R, you'll only have to solve for the component once again, which in our case for here is R theta dot equals negative the velocity of sine gamma. Make sure you do get the signs right for the direction. Then you solve for theta dot, and that is 0.0808 radians per second. And you can always check to make sure that your units cancel out. So if you were to divide by r here, then you divide out the distance, which is what you need for something that's in radians, because it is around the z-axis and has no distance. So we have now found both of these, and once you figure out the geometry and recognize that the r theta dot is perpendicular to r dot, you can simply break it down into components, which is one reason why we hashed that so much earlier on in the semester, because if you weren't completely sure how to break things down into the components, at this point the problem would still be difficult and convoluted to you. So once again, let me know if you have any questions, and you may want to subscribe. I upload the videos pretty randomly, so then you can know when I'm putting them up.